Hello everyone, let's try to solve this question from the chapter Force, Work and Energy. Let's go through the question and try to understand what is given in the question and what he is asking us to find out. The given diagram shows a uniform meter rule weighing 100 GF. So the scale is weighing 100 GF, pivoted at its center. Very important point. So this is the center. Two weights 150 GF and 250 GF hang from the meter rule as shown. So this is 150 GF and this is 250 GF. Before going into answering this question, let's try to understand one simple point. Okay, now because of its own weight, what will be the net movement? It will be net movement due to its own weight will be equal to how much? 100 into 0, because it's pivoted at the center itself. Its mass will be concentrated, or its center of gravity will be at this point, and it's pivoted at the center itself. So distance between center and center of gravity will be 0. That's why movement due to its own weight will be its weight into distance from center, that is 0. So again it will come to be movement due to its own weight will be equal to 0 GF centimeter units. Now let's try to calculate first question. Total anti-clockwise movement about O. Total anti-clockwise movement is in this direction. So in this direction it will be due to this 150 GF weight, right? So total anti-clockwise movement. Total anti-clockwise movement will be equal to how much? 150 force or weight into distance from the center is nothing but 40 centimeters, which is equal to 9000 GF centimeter. This is anti-clockwise movement. Now second, total clockwise movement will be equal to 250 GF into 20 centimeter, which is equal to 5000 GF centimeter. Now first question is over, second question is over. The difference of anti-clockwise and clockwise movements. So third question is nothing but T, which is larger, anti-clockwise movement, right? So anti-clockwise movement minus total clockwise movement is equal to 9000 minus 5000 centimeter, which is equal to 4000 GF centimeter. So third question is also over. Now final question is fourth question. What he is asking, the distance from center O where a 100 GF weight should be placed to balance the meters rule. So from here we need to place a weight 100 GF so that this will be balanced. When it will be balanced? If clockwise and anti-clockwise movements are equal. Now here you look out, anti-clockwise movement is more compared to clockwise movement. So we need to increase clockwise movement. We need to bring this 5000 to 9000 GF centimeter. So where we need to keep the weight? On the right side, because if you keep weight on the right side, it will increase clockwise movement. If we keep the mass at a distance of x centimeter from the center, this is 100 GF, what will happen? Total moment due to this extra weight will be equal to 100 GF into x centimeter. This should be equal to, this value should be equal to difference of TACM minus TCM, which is nothing but 4000, right? So this should be equal to 4000 GF centimeter, which will give you x is equal to 40 centimeter. So this 100 GF weight should be placed at a distance of 40 centimeters from the center to balance the meter rule.